Welcome back. This is Mr. Hassan's Maths channel, and I'm answering question number 2 from the February-March 2024 Cambridge 9709 A-level paper. This is paper 1, pure mathematics, and we have here a question about trig graphs. So the diagram shows part of the curve with the equation y equals k times sine half x, where k is a positive constant and x is measured in radians. The curve has a minimum point A. State the coordinates of A. So if we imagine what y equals sine x looks like if it was just as it was, then this would be 0, this would be pi, this would be pi over 2, this would be 2 pi. That's how it would look, okay, if it was just y equals sine x. And what's happened is you've got y equals sine of a half x. And this would be pi over 2, by the way, and this would be 3 pi over 2 in terms of pi. Okay, it says measured in radians, that's why I'm using pi. Okay, so that's what we would have if this was measured in radians and if it was just y equals sine x. Now, when you have y equals sine of a half of x, okay, what's happened there is it's like you've replaced the x with a half of x. So it's inside the function that the transformation is taking place. So it's only going to affect the x coordinates. Okay, so this part only affects the x coordinates, and it kind of does the opposite. So when it says when you multiply by a half, what it is, it's going to be a horizontal stretch because it's going to affect just the x coordinates, a horizontal stretch by scale factor 2. So you multiply the x coordinates by 2. Multiply the x coordinates by 2. Okay, 2 times the x coordinates. So basically, the point A has the coordinates 3 pi over 2 and minus 1, okay, if it's y equals sine x. So what's going to happen to that coordinate now? It's going to go to, okay, well, let's first work out the y coordinate. So we got y equals k times sine of a half of x. So the k part, what does that do? That's k multiplying the whole function. That's like k times f of x. So basically what happens there is that affects only the y coordinate. It affects only the y coordinate. So the y coordinate is going to be multiplied by k. All right, so the y coordinate of the original sine curve would be minus 1. So 3 pi over 2 minus 1 will become, multiply this by 3, you're going to end up with 3 pi. Sorry, by 2, not 3, by 2 because it's a half. So you're going to end up with 3 pi over 2 multiplied by 2, and you have minus 1 multiplied by k. The x coordinate multiplied by 2, the y coordinate multiplied by k. So the coordinates of the point A, therefore, are going to be 3 pi and minus k. Right, 3 pi and minus k. Okay, so that's how it would be if it's y equals sine of x, would look like this. So this would be y equals k times sine of a half x. The x coordinate multiplied by 2, the y coordinate multiplied by k. Right, so those are the coordinates of the point A after this transformation. So there's our answer there. So a sequence of transformations applied to the curve in the following order: a translation of 2 units in the negative y direction and reflection in the x-axis. Find the equation of the new curve and determine the coordinates of the point on the new curve corresponding to A. So we're starting off with y equals k times sine of a half x. So first we have a translation of 2 units in the negative y direction. So that's like 0 minus 2. Translation of 0 minus 2. So, but what happens is it's going to affect just the y coordinates and everything's going to go down. So you're going to have y equals k sine of a half x minus 2. That's the first thing. And secondly, it says a reflection in the x-axis. Now, reflection in the x-axis means it's going to go something like this. So it affects the y coordinates. The y coordinates will change their sign. So basically, the whole function will have a minus sign in front of it. So you end up with y equals minus in front of the whole function, k times sine of a half x minus 2. So you're going to multiply all of that by minus 1. So you end up with y equals minus k sine of a half x plus 2. Okay, that will be the new curve, the new equation. And then it says the new coordinates of A. So A starts off as we said, 3 pi and minus k. So what happens to this? What happens to it? First of all, you take away 2 from the y coordinate. So you're going to have, after the first transformation, it's going to be 3 pi, and it's going to be minus k minus 2. And then you reflect in the x-axis. So the x coordinate stays the same, but the y coordinate changes sign. So you end up with k plus 2 instead of k minus 2. So in both of these, this affects the y coordinate, this affects the y coordinate. The x coordinate will stay the same. The x coordinate will stay as 3 pi. Okay, but what changes is the y coordinate. First of all, you take away 2 from the y coordinate, and then you change the sign of the y coordinate. Okay, so this is the new coordinates of the point A after that transformation takes place as well. And that completes this question number 2 from the February-March paper. It's all about transformations of graphs. This is a relatively new topic actually in the Cambridge syllabus, transformations of Trig graphs, or even transformations in general. So that's something new. So what I'm going to do is I'm going to put a playlist over here. You'll link the playlist to the rest of the questions from this paper, from this particular paper. I'll put a playlist over here which takes you to my Cambridge transformations functions questions. But I'll put another playlist over here which takes you to the Edexcel functions transformation questions that I have there. So you can see other types of questions, because there's not that many so far on the new syllabus in the Cambridge syllabus. So you can see other examples from Edexcel. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.